Okay, here we go. The next little information that we're going to talk about is obviously oxidation reduction. We also have, so an atom will go, when you have a reaction, okay, and I'm sure you're all watching this on your computer screens right now, but when you have a reaction, something will go through oxidation. An atom will go through oxidation. That means because every time you have oxidation, you must have reduction, there will be one atom that goes through reduction as well. And so when something goes through oxidation, it's when the oxidation number of an atom increases. When it goes through reduction is when the oxidation number decreases, which makes sense. That's why it's called oxidation and reduction. The reduction is when the oxidation number decreases. Okay? Now what we also have when something goes through oxidation reduction, we also have what's called the oxidizing agent. The oxidizing agent is when there's something that's been, or it's the one that causes the oxidation of another atom. So the atom that decreases its oxidation number. So in other words, the one that is reduced is the oxidizing agent. And the one that is the reducing agent is the one that's gone through oxidation. All right? Now the best way I have to show that, and again I'm going to leave this here and you have the notes, but is to look at an example. Okay? So, here's an example of a reaction. All right? Here's an example of a reaction. Copper reacts with silver nitrate to form copper nitrate and silver. Cordero, what's the oxidation number of copper? 0. Why is it 0? Because it's alone. It's an uncombined atom, so it's alone. So copper is 0. Silver is going to be +1 because that's its charge. Oxygen is -2. What's the oxidation number of nitrogen? Silver, we have a +1. We have 3 at a -2, so that's -6. +5, right? We have 3. Notice that we have 3 oxygens at -2, so that's a -6. Silver, we only had 1, so nitrogen must be a +5 to make that 0. Correct. To make it 0. Okay? So there's the oxidation numbers for silver nitrate. Now the oxidation number for copper is going to be +2 because it's its charge. How do I know it's its charge? Because nitrate I know is a -1 and there are 2 of them, so I have to have a 2+ charge for copper. Oxygen is a -2. In this case, what's nitrogen? Well, we have a +2. We have 6 oxygens, right? The 2 on the outside go into the 3, so that's 6 oxygens, which means -12. We have 2 nitrogens, so what must its oxidation number be? Exactly. It must be still a +5 because we have 2 of them. So +5. But what must silver be over here? 0 because it's uncombined. Okay, so which one of these has been oxidized? Well, you're looking for the one that has changed. The copper goes from 0 to +2. So this one's gone up 2. And then notice that there's another one that has changed as well. The silver one has gone -1. Okay, so the copper went up +2. The silver has gone down -1. So Cordero is absolutely right. Whichever one went up +2, that's the one that's being oxidized. Okay, this one is the one that's being reduced. And again, notice the definition. Whichever one went from +1 to 0, it went down, so it's being reduced. This one's being oxidized. Now, whichever one is the oxidized one is the reducing agent. Whichever one was reduced is the oxidizing agent. Okay? So there you are. Let's go ahead and take a look at another one real quick as a review and as another example, I should say. But here you are. I'll do the balancing equations after. I want to just do this one first. So let's look at the let's assign some oxidation numbers. What's it for sulfur? 0. 0. What's it for hydrogen? +1. How about for oxygen? -2. What's it going to be for nitrogen? +5, right? Because we get the -6 with the the -2, yep. What's it for oxygen over here on the SO2? -2. So what's it going to be for sulfur? +4. How about for oxygen? And how about for nitrogen? +2. How about for oxygen and hydrogen? +1. Now, let's take a look at which ones have gone through the oxidation reduction. Okay? So, which ones have changed? S has changed +4, right? And which is the other one that changed? The N. So that one went down -3. You've got to make sure that you always have to have a +1 and a -1. All right? So there's your oxidized. And this one, of course, is reduced. So if I asked the question, which one was reduced, you'd say it was the N. And which one was the oxidized, you say it's the S. Okay? Now, how do we use oxidation reduction to balance equation? This would be a very difficult equation to balance. But you can use the numbers, the 4 and the 3, in the changes as as help in balancing the equation. All right. 4 and 3, what's the least common multiple? 12, right? Least common multiple is 12. So, what times 4 equals 12? 3. So, we're going to put a 3 in the front of the one that changed, S. Okay? What times 3 is going to be 12? 4. So let's put a 4 in front there. Now that gets us started for the balancing of the equation. So, now we balance an equation. We have 3 S's. Put a 3 in front of that S, right? We have 3 on both sides of the equation. Here we have 4 N's. Let's put a 4 there. And now let's take a look at our H's and O's. How many O's do I have on this left side of the equation? 12 O's, right? 4 times 3. And how many O's? Well, I've got 6. 4 more is 10. I only have 1 here, so how about 12, right? And let's just check our H's. Let me grab a different color here. What would be a good color?
I'd say red.
Yellow? Red's not going to be too good, Atencio. Okay. Let's look at our H's. How many H's here? 4, and how many here? 4. So there would be the balanced equation for that thing. Now, if you would have tried to balance that before without using the oxidation numbers to have a 3, 4, 3, 4, 2, that would have probably been pretty difficult. Okay? So that's that.